20 amps, which can be used as a disconnect in a garage if certain conditions are met. Firstly, consider the amperage rating. A 20 amp switch is suitable for a circuit with a maximum amperage of 20 amps. The total amperage of the appliances and lights in the garage must not exceed 20 amps. To calculate this, determine the wattage of each device and divide by the voltage, typically 120 volts for standard outlets and lights. For example, a 100-watt light bulb draws approximately 0.83 amps, calculated as 100 watts divided by 120 volts. Add up the amperage draw of all devices you plan to use simultaneously to ensure it stays below 20 amps. Secondly, address the voltage rating. The switch must be rated for the voltage of the circuit. Since a 3-wire number 12 cable is used, which is typically for 120/240 volt circuits, the switch must be rated for at least 120/240 volts. Ensure the switch's voltage rating matches or exceeds the circuit voltage to prevent switch failure or safety hazards. Thirdly, consider the number of poles. A double-pole switch has 2 poles, which means it can disconnect both the hot and neutral conductors. This is required for a 3-wire circuit. Single-pole switches only disconnect one conductor, which is insufficient for a 240-volt circuit or a circuit where both hot and neutral disconnection is desired for safety. The recommendation for circuit breaker size is as follows. A 20 amp double-pole circuit breaker should be used in the electrical panel to protect the circuit. This circuit breaker will trip if the total amperage of the appliances and lights in the garage exceeds 20 amps, preventing the circuit from overheating and causing a fire. The circuit breaker acts as a safety mechanism to prevent overloads and potential hazards. Switch placement is also important. The switch should be placed in an easily accessible location inside the garage. It should be close to the entrance so that you can quickly disconnect the power in case of an emergency. Consider mounting the switch near the door frame at a standard height for easy reach. For the installation, the switch should be installed by a qualified electrician according to local electrical codes. Proper installation will ensure the safety and reliability of the circuit. Electrical codes vary by location, so it's crucial to adhere to local requirements. A qualified electrician has the expertise to install the switch correctly and safely. To elaborate on calculating the load, one must understand how to convert wattage to amperage and account for continuous loads. The formula to convert watts to amps is amps equals watts divided by volts. For a 120-volt circuit, if you have a device that consumes 600 watts, the amperage draw is 600 divided by 120, which equals 5 amps. It is important to consider continuous loads, which are loads that operate for 3 hours or more at a time. According to the National Electrical Code, or NEC, continuous load should not exceed 80% of the branch circuit rating. For a 20 amp circuit, the maximum continuous load should be 16 amps, calculated as 20 amps multiplied by 0.80. This means that if you have a device that operates continuously, such as a refrigerator or a space heater, its amperage draw should not exceed 16 amps on a 20 amp circuit. Regarding wire sizing, using number 12 wire with a ground is appropriate for a 20 amp circuit. Number 12 copper wire has an ampacity of 20 amps according to NEC table 310.15b16. It is crucial to use the correct wire size to prevent overheating and potential fire hazards. If the circuit were to carry more than 20 amps, a larger wire size, such as number 10 copper wire, would be required. The ground wire provides a path for fault current to return to the source, which helps to protect against electrical shock. It is important to connect the ground wire to all metallic enclosures and devices in the circuit. When selecting a double-pole switch, ensure it is rated for the appropriate voltage and amperage. The switch should have a UL listing, which indicates that it has been tested and certified by underwriters' laboratories for safety and performance. The switch should also be rated for the environment in which it will be installed. If the garage is damp or wet, a switch rated for wet location should be used. Installation of the switch involves several steps. Firstly, turn off the power to the circuit at the main electrical panel. Use a voltage tester to verify that the circuit is de-energized. Secondly, connect the wires to the switch according to the manufacturer's instructions. Typically, the black wires, which are the hot wires, are connected to the terminals marked line, and the white wires, which are the neutral wires, are connected to the terminals marked load. The ground wire is connected to the ground terminal, which is typically a green screw. Thirdly, mount the switch in an electrical box. The electrical box should be securely fastened to the wall. Fourthly, install a cover plate over the switch. The cover plate protects the switch from damage and prevents accidental contact with the electrical connections. Finally, turn on the power to the circuit at the main electrical panel. Test the switch to ensure it is working properly. When installing the circuit breaker in the main electrical panel, it is important to follow the manufacturer's instructions and local electrical codes. The circuit breaker should be properly sized for the circuit and should be installed in a vacant slot in the panel. The wires should be securely connected to the circuit breaker terminals. The panel should be properly grounded and bonded. It is recommended to label the circuit breaker so that it can be easily identified in the future. Regarding placement of the disconnect switch, it is often recommended to install it near the entrance of the garage so that it is easily accessible in case of an emergency. This allows for quick disconnection of power to the garage if needed. Another important consideration is the proper grounding and bonding of the electrical system in the garage. Grounding provides a path for fault current to return to the source, which helps to protect against electrical shock. Bonding connects all metallic parts of the electrical system together, which helps to equalize the voltage and reduce the risk of shock. The grounding electrode system for the garage should be connected to the main electrical panel in the house. The grounding electrode system typically consists of a ground rod or a metal water pipe that is buried in the ground. It is crucial to use a correct size and type of grounding electrode to ensure effective grounding. Additionally, consider surge protection for the electrical system in the garage. Surges can damage electronic devices and appliances. A surge protector can help to protect against surges by diverting excess voltage to the ground. Surge protectors can be installed at the main electrical panel or at individual outlets. When running the wiring to the garage, it is important to follow the NEC guidelines for underground wiring. The wiring should be buried at the proper depth and should be protected from physical damage. The wiring should also be properly labeled and identified. If the wiring is run overhead, it should be installed with sufficient clearance from the ground and other objects. The wiring should also be protected from weather and physical damage. The NEC provides specific requirements for the type of wiring that can be used for underground and overhead installations. When installing outlets and lights in the garage, it is important to follow the NEC guidelines for spacing and placement. Outlets should be spaced no more than 12 feet apart, so that no point along the wall is more than 6 feet from an outlet. Light should be placed to provide adequate illumination for the work area. It is also important to consider the type of lighting fixtures that are used in the garage. LED lighting is energy efficient and long-lasting. Fluorescent lighting is also a good option for garage lighting. Incandescent lighting is less energy efficient and has a shorter lifespan. When installing a garage door opener, it is important to follow the manufacturer's instructions and local electrical codes. The garage door opener should be installed on a dedicated circuit. The circuit should be protected by a ground fault circuit interrupter, or GFCI outlet. The GFCI outlet will trip if there is a ground fault, which helps to protect against electrical shock. It is also important to ensure that the garage door opener is properly grounded. Regular maintenance of the electrical system in the garage is important to ensure its safety and reliability. The electrical system should be inspected periodically by a qualified electrician. Any damaged or worn components should be replaced. The circuit breaker panel should be kept clean and free of debris. The grounding system should be tested to ensure it is working properly. It is also important to educate yourself about electrical safety and to follow safe practices when working with electricity. Always turn off the power to the circuit before working on it. Use insulated tools. Never work on electrical equipment when you are wet. If you are not comfortable working with electricity, hire a qualified electrician. In summary, using a 20 amp double pole switch as a disconnect in the garage is permissible under specific conditions. These conditions encompass ensuring that the total amperage of appliances and lights remains under 20 amps, the switch is rated for the appropriate voltage, and a double pole switch is employed to disconnect both hot and neutral conductors. A 20 amp double pole circuit breaker should be used for circuit protection. Correct switch placement close to the entrance is vital for easy access. Lastly, a qualified electrician should perform the installation in compliance with local electrical codes to guarantee safety and reliability. These guidelines ensure a safe and functional electrical setup in the garage.